Okay, in the last video, we determined the water crystallization of some sodium carbonate using a titration method. In this one here, we're going to do it a different way, called a gravimetric method, which is just a fancy way of saying you do it by weighing it. Okay, so what have we got here then? Well, we've got some copper sulfate hydrated. Okay, so we've got a crucible. And we've got some hydrated copper sulfate, so we know how much we've got in there. Well, we can work out how much we've got in there. And then we heated that with a Bunsen. And that will drive off all the water, so you'll end up with some, this will now won't look blue anymore, it'll look like a white powder, and all the water will have gone. Okay. Now, this is going to weigh more than that because the water's gone there. So we write down a little equation here. We can see we've got copper sulfate dot XH2O, and we're going to heat it up. It's going to go to copper sulfate. I'll put state symbols in. That's a solid. That's a solid. And we're going to get X molecules of water, whatever X may be, coming off as a gas. Okay, so let's see what we've got here. We've got the empty crucible here, and we've got the mass with the crucible with the hydrated copper sulfate in it. So by subtraction for these two, it's quite easy to find out. Let's write down the mass of copper sulfate XH2O. That's going to be equal to 21.11 minus 15.76 grams, which is equal to 5.35 grams. Okay, so let's write that down there, 5.35 grams. Now, what's going on here? It says here, the crucible and its contents here were heated to remove all the water crystallization, left to cool and reweighed. To ensure all of the water crystallization had been driven off, the crucible was reweighed to constant mass. What does that mean? Okay, what it means is they heated it first of all here, and its mass has gone down to 20.01. How do you know that that's all of the water? Well, you don't. Okay, so you heat it up again, yeah, and you reweigh it, and the mass has gone down. So it looks like, yeah, there, at this point, it hadn't been fully dehydrated because its mass had gone down again. So then you heat it again and reweigh it, and you find this time the mass hasn't gone down any further. So that would appear, this is constant mass, yeah, that would appear that you have, the reason why it's not going down anymore is because all of the water is being driven off. And this weighing to constant mass is a fairly standard technique, okay? And it's a fairly standard exam question, you know, will say something like, they do this experiment, they don't weigh it to, you know, they don't quite get the right answer, and they've only weighed it once. They haven't reheated it and kept on doing it until the mass stopped going down. And so what was the fault of the experimental design? So, well, you should have heated it to constant mass. They obviously haven't got rid of all of the water. Okay, anyway, so the mass of the copper sulfate there, let's see. So what is going to be the mass of the anhydrous copper sulfate? Well, that is going to be the mass of the crucible, 21, sorry, it's going to be the mass of the crucible with this one here. So 19.18 minus the empty crucible, 15.76, and that is equal to 3.42 grams. So I'll write that down there. Now, there's actually two ways of working out of doing this here. So we'll probably do them both, yeah? Right, so let's see, what does this equation tells us? It tells us that 1 mole of the hydrated stuff gives us 1 mole of the dehydrated, of the anhydrous. Can we work out the moles of the hydrated. So moles is equal to mass over mR. We can't work out the moles of the hydrated, though, can we? Because we don't know the mR, because we don't know what the value of X is. So we can't work out that, okay? But what we can work out is we can work out the number of moles of the anhydrous stuff, because we do know the mR of copper sulfate anhydrous because there's no water in it. So let's do that. So moles of the anhydrous is equal to 3.42, well, mass over mR. Let's do it properly. Mass over the mR, 3.42. Now the mR of this is 63.5 for copper plus 2.1 for sulfur plus 4 times 16. That's equal to 159.6. So do that in a calculator. 3.42 divided by 159.6 is equal to 0.0214 moles. Okay, now we know from the equation, we know that 0.0214 moles of the hydrated stuff, of the anhydrous, comes from 0.0214 moles of the hydrated one. Okay, so now we know two things then. We know the number of moles of the hydrated copper sulfate, which is that, and we also know the mass of the hydrated copper sulfate, which is 5.35. So if we know the moles and the mass, we can work out the MR. So moles is equal to mass over MR. So the MR is equal to mass over moles. What was the mass of the hydrated stuff? 5.35 grams. And the number of moles was this, 2.0214. Do that on the calculator. What do we get? 5.35. That gives us 249.67. Okay, so now we should be able to find out X, shouldn't we? Because look, I just put down our, right, here is our copper sulfate dot X H2O. We know that this bit weighs 63.5 plus 32.1 for sulfur plus the oxygens. That's 159.6. So that means this bit here has got to be equal to 249.67 minus 159.6, which is equal to 90.0. Okay, so how do we find out X? Well, one molecule of water weighs 18, so X is going to be equal to 90 over 18, which is equal to 5. It works out as a whole number in this case, and we know it's got to be a whole number. So we know the water, so the formula is copper sulfate dot 5H2O. Okay, that is one way of doing it, and we'll also do a different way, just as good, gives us the right answer. So let's just rub all this stuff out. I'm going to leave those masses there, that'll be quite useful. Okay. Okay, so how are we going to do this one? This is a different way. Right, you might be able to see how we're going to do this. Well, look, we've got 5.35 grams of a hydrated stuff, and we've got 3.42 grams of the dehydrated stuff. So that means we know how much water we've lost there with mass of water. We can do that. It's going to be 5.35 minus 3.42. Let's do that. So mass of water is equal to 5.35 minus 3.42, which is equal to 1.93 grams. Okay. Now, what this formula means is CuSO4.xH2O is we want to find out the ratio, yeah, of the moles of copper sulfate to the moles of H2O. Okay, so how can we find out the moles of each of these things? Well, moles is equal to mass over MR. Okay, so how many moles of copper sulfate have we got? So let's do that. Moles CuSO4. That's going to be the mass of it. Now this is the anhydrous stuff, so that's 3.42 grams divided by the MR of that, which we know is, we worked it out before, is 159.6. And we know the moles of the water. Well, that's mass over MR. The mass of water is 1.93, and the MR of water is 18. So let's work out those two. So this is the ratio now. Okay, this is the ratio of the moles. So 3.42 divided by 159.6 is equal to 0.0214. Okay, and the moles of water, 1.93 divided by 18. That's equal to 0.1072. Now, how do we simplify a ratio? Well, you divide by the smallest number you've got. Divide through by smallest number. What is the smallest number out of these two? It's 0.0214, isn't it? So the ratio is going to be equal to 0.0214 over 0.0214 to 0.1072 to 0.0214. That's obviously going to be 1. And then with this, we're doing the calculator, divided by 0.0214 is equal to, right, it says 5.01 on my calculator. Now, it can only be whole number values, so we can say, therefore, X is equal to 5. So the formula is copper sulfate dot 5H2O. Okay, so both ways give you the same answer, both ways just as good as each other.